guys, in today's video we're going to look at equilibrium constants. What are they? Factors that can affect them, looking at the effect of temperature, the effect of concentration and pressure, and the effect of using a catalyst. And finally, we'll look at an exam style question.
So let's begin by looking at what exactly they are and their significance. Well, we know our equilibrium constants to be either Kc or Kp, where Kc takes into account the concentrations of the reactants and products, and Kp the partial pressures. Now, the magnitude of our equilibrium constant indicates the extent of chemical reaction. So if our constant K is equal to 1, that signifies the equilibrium lies halfway between our reactants and our products. If the constant is less than 1, that signifies the equilibrium lies to the left, it favours the reactants. If the constant's more than 1, it signifies that it lies to the right, favouring the products. So let's have a little look at the factors that affect our equilibrium constants. Well, the equilibrium constant K is only affected by temperature. No other factors affect it. We had a look in our previous video about the effect of temperature on our rate constants and how they're related in an exponential way and how the Arrhenius equation ties this together. But the shift in position of equilibrium are controlled by our rate constant, and so shifts will only occur when temperature is changing. When anything else affects our system, the rate constants, the equilibrium constants, remain the same. They remain constant. So let's have a look and remind ourselves about the effect of temperature on our rate constant. Well, it depends on the delta H value. It depends if our forward reaction is exo or endothermic. Generally, if we increase the temperature, the equilibrium will shift in the endothermic direction. And if we decrease temperature, it will shift in the exothermic direction. Now, if our forward reaction is endothermic, the value of K will increase with temperature, driving the equation to the right-hand side, to the endothermic side. And if the forward reaction is exothermic, K will decrease with temperature, driving the reaction to the left-hand side, to the endothermic side. So temperature is the only factor affecting our rate constant. So let's now have a look at how the effects of concentration or pressure affects our equilibrium system. Well, we know the rate constant K is completely unaffected, but what happens is our equilibrium shifts to restore the value of K, because the value of K, our constant, changes and we no longer have an equilibrium. So if we had this equation here, A is in dynamic equilibrium to form 2B. We know our equation for our rate constant would look like this. We'd have B squared, this is 2 moles of B, divided by the concentration of A. Say, for example, we had 0.1 moles of A and 0.2 moles of B. You can see that our rate constant will take a value of 0.4.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, click the button. Join me today and together let's make A-level chemistry a walk in the park.